Hello. Hello, hello.
Hi, Professor.
Thank you. That is doubly great. Thank you for saying hi, and thank you for saying hi, because I was not sure if any of this audio was working. Okay, good afternoon. So yes, hello, and I'm not even sure, actually, sorry, hello, Fahima. Good afternoon, Noreen. Hello, Almadina. Hello, Kareem. Hello, Cassandra. Hello, Kazi. It was good, thank you. Hello, Charles. Hello, Grisella. All right, I'm not even sure who actually said hello, but thank you for saying so. Hello, Shasha. And someone else is here. Wait, okay. Oh, hello, Rachel. Sorry, I mean, hi, Rachel. Sorry. Okay. Oh, and Yulia is here twice. That no, okay. Okay. Hello. I said Shasha. Okay, so I think that's so. Yes. Hello, Cassandra. Hello, Rachel. Hello, Fahima. Hello, Kareem. Hello, Almadina. Hello, Noreen. Hello, Shasha. Hello, Charles. Hello, Grisella. Hello, Kazi. Hello, Hannah. Oh, it was Hannah. That's who ended more people. Oh, and warning, I think we're all about to say hello to my son. Oh, me, it was you. Oh, hello, Yulia. Sorry about that. Okay, we are about to be interrupted. I am fairly confident it should be a short interruption. Well, I'll say this quickly while, oh, and more people are coming. I'll tell you what we're gonna, we do have the double period today. Thank goodness. I know it's long overdue. I owe you so much. Hello. Oh, thank you. And hello, Adriana. Sorry about that. If I missed that, hello. I will warn you quickly what we're going to do. Hello, Kwan. Sorry, hello, Kwan. Okay, we are going to have the double period. I'm not going to talk for 2.5 hours. We're going to work. We're going to, as promised or as indicated, we are going to start preparing ourselves for the final exam today. Like as promised, like I don't want you just like thrown in there, with no preparation. As promised, there will be something that you can do for optional points before we get to the hello, hi.
I am not a person.
Oh, you're not a person. Okay.
I'm kidding.
How did it? Pardon me. How did it go? Did it go good, guys?
Yep.
Yeah, it was good.
Okay.
Easy.
Yes.
I'm sorry.
No.
Whoa,
No.
dude. I'm sorry. And now, okay, pardon me, everybody. Okay. Okay.
Sorry.
It's okay. Okay, now I'm going to teach. Okay. Nothing broke. Okay. Oh, and people are coming. Okay. But it was good. Was mom good? Was it good?
Yes.
Cool. Okay. I will see you after.
First fish.
Okay.
Fish.
So,
Fish.
hello.
Fish.
So what we are going to do today is mostly work on practicing for the final exam. We have one more class next week where we will directly answer questions and directly address concerns that might have built from now to then. Prior to the last class, I will have posted I will post updates and corrections and some solutions and okay. Wait, sorry. All right, so a little hard for me to focus at the moment. The final is going to be posted. It's going to be posted after the last class. I'll put this in Google Classroom momentarily, but our last class is next Wednesday. The last classes in general, correct me if I'm wrong, I'm going to look this up again, and is the following Monday or Tuesday, right after the last. So I'll put this, sorry, I'm a little bit distracted at the moment, but what I'm trying to say is that I'm going to post the actual final exam a couple of days after classes end. In other words, a couple of days, and then it'll be due at the end of the final exam period. I will, okay. I'll put this formally in the classroom in a few minutes. But the point is that the final exam is a take-home exam. Remember, it will be posted prior at the beginning of the final exam period, and it's due back at the end of the final exam period. So,
I have fish.
and in the last class, yes, right.
Everybody
okay,
say
okay,
hi.
Okay. Hello. They say hello. They're there. Okay. Cool.
I don't even know how to spell hello,
Yes.
even though I'm in first grade.
Wait, okay, I have to teach that, but you do.
Okay, bye, weirdo.
Okay. I'm going to wait. Is it going to be next week? Wait.
Where are you?
Yeah. So, you'll certainly be given a given sheet. Oh, yes, but more than that. But also remember, the whole thing is take home anyway, and it's open universe. So you will have a given sheet, but you'd be able to look in your notes anyway, legally. But more to the point, even more to the point, and this is what we're here to focus on today. Hopefully you'll see in your Google Classroom, as of about 10 minutes ago, I posted a practice document, a document which strongly resembles, strongly resembles what your actual final document will look like, okay? And most of what we're going to do today, even though I'd still like to cover a bit more material, I'd still like to tie up some loose ends, I'd still like to explain some things, and wait. Okay. Sorry, okay, now it's a little quieter here so I can focus. Okay, I love Hannah's question. I think I understand Hannah's question. I will try to answer it in 1 minute. Let me just finish. So the main thing I'm trying to say in general is that today, like many of these concerns or questions about what the final exam will feel like or be like or so forth are all super legitimate questions, of course. Super legitimate. But many of them are going to be answered because today we're more or less going to practice for that final exam. Like what you're going to see in a moment or two, or if you don't already, is that in your Google Classroom under materials, under exams, I posted a practice document, a document that more or less is your final exam. You're going to learn a little bit more before you get there. I'm going to adjust some of the questions. It'll be cleaned up, tightened up. Some of the things will be altered, not even to make it harder or not even to make it more surprising, but just to make it more exactly sort of like what we've done here. But to give basically a very, very strong idea of what your final exam will look like is currently in Google Classroom. And again, we're not trying to trick you here. We're actually trying to reduce as much of the surprise factor as possible. So most of today, what's going to happen once like I start yammering and after I answer a couple questions like Hannah's and others, mostly what's going to happen today is it's sort of going to be like a lab period or a board meeting period or whatever, where we're going to sit here and on your own time, you're going to work through various parts of this practice document to sort of get yourself used to it and up to speed. And you'll have opportunity to talk to each other by whatever means you normally do and ask me and stuff like that. And so it's going to be a more of an informal but long study period to prepare for the final exam. Now, okay, so a lot of your questions will be answered because, again, the document that you might, hopefully you'll see it, maybe someone will confirm for me in a moment. The document that's in Google Classroom right now, that's called practice document, is there. Okay, great. Thank you, Hannah. I appreciate it. It's okay, great, Noreen. Awesome. And don't start doing it yet. Like we will start in a moment. I'm gonna, but I want to alert you to like sort of what order to go in. And there's definitely parts already in there that won't seem familiar yet, but then a lot of parts will, blah, blah, blah. So we're going to dive into it in a moment. But as far as then Hannah's question, we can use equations for that. Yeah, the short answer to Hannah's thing, well, sorry. So in the chat, it says, for physics 101, we could only use equations from the given sheet, and any other ones we had to show how we derive them ourselves. Is that the case for 102 or no? Yes. We don't do it exactly the same way, but yes. But here's the basic deal for 102. The basic deal for 102 is what this course is all about is the motions, like our main givens or our main equations, at least by the time we get to the final, are the motions that you've been steadily developing in lab. And you will see I believe you'll see when we open up this document together in a moment, you will see there is at least one page in it where basically the motions of this class have been presented there. I can't remember if they're presented in order or not, but those, pretty much anything you do on your exam should be coming from those givens. And right, like Hannah's saying, anything more elaborate that you say equation wise should be derived from there. Now, I'm not sure you're doing as much derivation of equations here as you might have done in 101, but yeah, so yeah, let me, in fact, what I think I'm going to do, so we're going to break up, I mean, somewhat momentarily and just start looking at this, but what I'm going to do is switch screens. I'm going to share, since 2 people have confirmed that they do see it in their Google Classroom, let me actually share it on, so I can just tell you how to. And again, this is practice. The thing to understand about this document that is now being shared, I believe. Hello. Is it still there? Yeah. Okay. The thing about this document, the practice document, and something's in the chat. I'm sorry. Hold on. Oh, okay, cool. Okay. The good news and the bad news about this document. The good news is, again, it is meant, oops, someone's here, sorry. Okay, the good news about this document is it is meant to be as close as possible to your final as it can be. In fact, like, honestly, it also helps us right there. Like, honestly, if I literally had your final ready right now, I would pretty much post it as the practice document. The point here is not to have you go into a guessing game mode, or it's not about, like, your final exam is not about, oh, I wonder what's going to be on it. Oh, he's going to try to outsmart us and we're going to outsmart him. Like, no, like, I want you to know what's on the final before you take it. So this thing is supremely close. The thing is that it's a rough draft. We still have to improve some things. I mean, every semester the class goes a little bit differently, especially these days, doing it all on Zoom and all of that. Like, I only want to ask you questions about what you've emphasized, blah, blah, blah. So as we get closer to your actual end of the semester, I will be updating and improving this thing to make it closer and closer to what it actually needs to be for your final exam. As I make significant updates to it, or as both of us do, we will alert you. So this thing is going to evolve into your actual final exam, if that makes sense. Like, there will be some differences, but mainly you're trying to get to know this thing as well as you can, so that by the time it's actually posted for the exam period, you'll go home on your own time, in your own way, under non-test conditions. You will use the web, you will use your notes, and you will use one another to try to do everything you can in order to submit a complete response, thorough, clear, colorful, explanatory set of responses to the final exam document. Like, you'll submit on separate pieces of paper as though they were a blue book. And it'll all happen in Google Classroom. This thing will be posted at the end of the class, after classes are all over. You'll return it to Google Classroom as though it were just one big assignment, only it counts as an exam. And you'll return it at the end of final exam period. I will put the exact dates into Google Classroom. I keep getting confused of exactly which day classes and stuff. Well, here, hold on 1 second. I know we do have it here. 1 second. I'll just say this right now. Yeah. Right. So classes end. Oops, sorry. Right. Classes actually end the 13th, which means we don't have the benefit of having a class on the 15th. So that's why I'm trying to sort of deal with this right now with all y'all. We won't have class the 15th, but there are classes through the 13th. So next week is the last opportunity we'll have to talk about all of this and to answer questions and to go over this kind of stuff. But we still have class up until the 15th, up until the 13th. So something like the 14th or 15th or something like that is when and again, I'll put that exactly in Google Classroom, but something like the 15th is when I will post your actual exam, and then final exam, and then it'll be due something like Monday the 20th or something like that. Okay, I mean, I'll be exact in Google Classroom, but you'll have that week to do it, and it's open universe. The idea is just to show it. So think of it more like a research project, if you like, or poster presentation, whatever. Your job is just by the end to show that you understand everything that you understand by the end. You're not trying to show that you originally came up with everything, and you're not trying to prove or pretend that you didn't help each other learn. You're just trying to say by the end, when you fill out your exam document, you're attesting to the fact that everything you write down, you actually understand. And how are you attesting to that? How can you prove it, or how can we enforce that? Well, the better you understand it, the more you say, if you follow me. Like, you're there to show your understanding as thoroughly as possible. Let me just look in the chat. Hold on. But again, as far as the format of this test and the weirdness of it, or whatever is quirky about it, that's what we're going to sort of get used to today. Let me just look in the chat. Oh, okay. So, no problem. Oh, quick. Classes end on Monday the 13th. Okay, right, got that. Kazi, your final, well, it may be about as long as this. This thing does look long, but when I walk through it with you in a moment, you'll see that I think it's less intimidating than the page length might look. But yeah, more or less your exam will be, the exam document will be as long as this one. Yes, that doesn't mean, I mean, yes, to answer Kazi's question, I think your exam will very much look like this. But as we walk through it in a moment, I think you'll see it's not quite what it looks like. Thank you. No problem, Kwan. Thank you for saying thank you. Okay. Now, and again, mostly today, I don't even want to talk. I don't think you want me to talk. Mostly, I want to give you a chance to go through this. But let me just quickly. And again, also, yours won't be, let's say, answer Kazi's question and just also to cover myself and be honest as possible. Yours won't be exactly like this. This will evolve a little bit and become more exactly yours, but in any significant ways that we change this to make it more yours, we will alert you that we're not going to, this is imperfect, it's rough, it's old. You know, I mean, it's what we did a couple of semesters ago. I mean, it's from what we did a couple of semesters ago. So I want to adapt it and make it more exactly appropriate to you. So I need a little time for that too. That's also why we're doing this now. But whatever major changes we make to it, we will alert you. Hold on. I'm looking at the chat again. Oops, sorry. Oh yeah. Wait. Okay. I'm sorry. I'm looking in the chat. There will be a format, a suggested format for anything you have to solve, but you'll see when we look at this exam in a minute, for a lot of it, it won't even be necessary. But yes, whenever you're solving an actual problem, we want you to do that 5-point, or what do you call it? That 5-step problem solving process that you did in the homework. That was the point of that. Yes, please. Now, as for Yulia saying, of course, it's totally fair what Yulia and Fahima are asking. I agree with that, Julia. No, I will definitely post an announcement with the dates. I will in Google Classroom. The only reason I'm not right at this moment is because I still have to work them out exactly with Walters. Here, you know what I'll do right now, though. But no, I will. I mean, the answer is I will. I'm just giving you a rough idea now that basically the exam will be, and you might just make an informal note of this, please. But yes, I will in Google Classroom. I also don't want to box myself in. I want to leave it a little bit flexible right now. But basically, cool. You're welcome. No problem. Basically, though, what I'm saying is basically we will post the exam around Tuesday the 21st. Sorry, that's not what I mean. We will post the exam around Tuesday the 14th. Or Monday the 13th, maybe even a little bit before, but it'll be due around Monday the 20th. It'll be due around Monday the 20th. I mean, I'll even say this now. I still don't want to write this down because I need to confirm with Walters and everything. But, you know, I think what I'm saying is probably, because we could probably post it before the last one. Probably, honestly, we'll post it. So you don't even have, Yeah, probably. We'll probably post it something like, okay, you can write this down. I will type this, but something probably more like Friday the 10th around there. We'll post it probably to give you as much time as we can to do it. And then it'll be due like Monday, the 20th. I mean, we need a little time to grade it and turn in the grades too. So figure Friday the 10th. Yeah, I'm pretty much saying this. And I might even formalize this by the end of today's class. I might even put this in Google Classroom. But right now, what I'm really saying is Friday the 10th when we'll post it, just to ruin your weekend. And then Monday the 20th, it'll be due. Okay, I think that's what I'm saying. Friday the 10th, we post it. Monday the 20th, it'll be due. And please do make an informal note of that for your own sake, but I will formalize that. But we're saying, oh, someone's here. Okay. Oh, also, I should just be clear. This is right now Physics 102. Everybody knows that, right? We're in Physics 102 here, not Physics 203. Okay. What I want to do now is briefly, I just want to walk you through for a second. Wait, I was screen sharing, wasn't I? Am I still screen sharing? Yes. Okay. I want to just quickly show you how this thing works. I mean, it's a little unusual. That's also why we're giving you time on it now. Again, this is a practice document. Again, let me reinforce this practice document that you are going to work on today. Like the bulk of time today, you're going to work on this. I'll turn off the recording and blah, blah, blah. I don't even know why any of this is being recorded. But anyway, you're going to work on this. You're never turning this thing in. You turn in the actual final exam once it's posted, and whatever separate section of this that we all agreed that I'm going to post for optional points, I'll make that clear when I do it, and you'll turn that in. And frankly, what that may be involved, that might involve like watching a long video that you'll just screenshot and show some evidence that you watched, and you'll get points for that. I mean, a video, because I owe you instructional time still, and I'll put that into a long video somehow. But anyway, this thing that I'm about to show you is practice for the real thing. You're not turning this in, but it's super close to the real thing. So the better you can understand this and do it, the better. So here's the deal. I'm walking you through it right now. Okay. So hopefully please turn to it or watch the screen or whatever. And again, even though details will be changed to protect the innocent, like the basic structure and format of this is how we do it. So on the very first page, you'll notice it has like a little bit of like news reference, a little bit of philosophy, whatever. I'll try to put that in perspective. We're trying to put the whole course in perspective. I'll try to do that for you by the end of today and by next week. And I think I've mentioned this before. The real deal is that we care a lot about the Doppler effect. The Doppler effect we've studied a lot in the context of sound, because for many reasons, but one, because it demonstrates the nature of an unthingy thing. It demonstrates the nature of propagation rather than simple motion, right? The propagation of information rather than the trajectory of a particle. Big theme of this course, big part of this course. Well, it does turn out, we sort of want you to see by the very end, by next week, we want you to at least be exposed to the idea that if you look at light in a certain way, it turns out that light often behaves like a wave. It moves like a wave, not just a particle. Now, we haven't fully shown this to you yet. I'm asserting it since the course is starting to wind down. If light is put under certain conditions or observed in a certain manner or subjected to certain experimental apparatus, such as a thing called a double slit experiment, which you may have heard about in other courses and stuff. When light is subjected to certain circumstances, it demonstrates wave behavior. I'm asserting that right now. I think you will see that more and talk about that more in the very last lab with Walters, probably. If not, you're going to discuss it a little bit more explicitly with me in the very last class next week. But I'm asserting right now to help you put this material together. And I'm sure you've heard it before, that light under certain conditions does in fact demonstrate wave characteristics. It moves like a wave under certain conditions. Furthermore, it turns out that light, when it's coming to us from stars, demonstrates a Doppler shift. Now, we've spent a long time talking about the Doppler effect, a long time, which is why right from the get-go in this exam, you're asked to practice or demonstrate your knowledge of the Doppler effect. I'm going to direct your attention to that in 1 minute. But just so you understand why and what's going on and why it's like in the middle of this like weird picture and this National Geographic excerpt right on the front page, because it turns out that, and again, I think I have mentioned this before, but it turns out that the light from stars as it comes to us from Earth demonstrates a Doppler shift. The light as we receive it seems to be more toward the red side of the frequency spectrum than it was in the frame of reference of the star from which it left. Light seems more red from the Earth's frame of reference than from any given star's frame of reference. Red is lower frequency than orange. Orange is lower frequency than yellow. Yellow is lower frequency than green, et cetera, et cetera. So if light appears to us to be lower frequency in our frame of reference than it does in the frame of reference from which it left, and if light is behaving like a wave, then according to Doppler effect analysis, that means that stars, the stars that are the source of this wave, stars must be moving back away from us, receding, right? If you follow the whole Doppler effect analysis, when the source of a wave recedes from the receiver of the wave, then the frequency of the wave as measured by the receiver is lower than the frequency of the wave as measured by the source. Like that's like, I mean, it's not an easy point, but it's the point that we keep sort of trying to practice with all those Doppler effect problems that we were doing. If it's true that light waves do this, which they appear to do, and if it's true that light waves from stars do this, that suggests that stars on average in general are moving away from us. That is, in fact, the inference to which we come. That is, in fact, our belief that in general, stars are always moving away from us, i.e., the universe is expanding. It's a very deep conclusion to come to. You might be so used to it, you might have heard it so many years of your whole life that you might just take it as a given. But it's a weird idea. In fact, if I'm not careful, I'll go a little too nuts with that idea right now. But I mean, it raises a lot of questions, such as if we say the universe is expanding, like into what? I mean, normally when we say something expands, what we mean, like if we say a liquid expands, what we mean is it begins to occupy a greater and greater amount of the space of its container, right? If we say a liquid expands, we mean it occupies more of the container that it's in, or it takes up more and more cubic centimeters of volume, let's say. But if we say the universe expands, universe is the sum total of all space and time. If we say that the totality of space expands, then we're not just saying that stuff is taking up more space, we're saying that space itself is taking up more what? I don't know. It's a really weird idea. But we apparently believe it because we apparently have no choice but to believe it, because apparently things are spreading out all the time. Into what? I don't know. That's why it's interesting to think about. But if you believe the Doppler effect and you believe that light is a wave, then, and you believe that starlight is exhibiting a Doppler effect, then you come to, then you, if you're me, if you're us, if you're we, come to the conclusion that stars and the stuff of the universe in general is getting more and more spread out as time goes on. That's such a big conclusion. It's kind of the big conclusion of this course. So the meat of that conclusion has to do with the Doppler effect. So right from the get-go in this exam, you're asked to do a simple Doppler effect problem. Now, I'm going to tell you right now, again, I'm going to not talk this whole period. I'm sorry, I'm already talking more than I wish to, but I'm going to warn you right now. Like, you see how right on the first page, it asks you to do a exercise in the Doppler effect. When I stop talking, when I release you, I'm going to ask you to, on your own time, do that and get an answer. But I'm going to warn you right now. Wait, okay, cool. I'm so psyched. Actually, she's so nice. I'm going to miss you people, but cool. Okay. Cool. I'm so easily thrown. Remember, they didn't really have ADHD when I mean, they had it, but they didn't, anyway, they just called it fish. Okay. God, nothing like throws me off. All you do is compliment me in the middle of the exam, and then like you'll all just get it. Okay. My point is right. So right away you're gonna have to practice a Doppler effect. Now I'm gonna warn, and there's more Doppler effect. Doppler effect is kind of like the hub of the gist of the nub of it's like very much strewn throughout this exam. If there was anything to like practice over and over from a million different points of view, it would be the Doppler effect. And I do want to warn you right now that right here in this old version of the exam, you see there's just like, there's one problem, kind of one case. I'm going to tell you right now that as we adjust this exam and make it more yours, you're going to have to do more than one case. In fact, for sure, one of the ways you're going to get extra points, if you want extra points on like a separate, like midtermish document, is to compare a bunch of cases. So I will tell you right now, like right here, it asks you to do one case. I absolutely advise you strongly, even today, if you start getting itchy in one direction or another, maybe split up into groups or whatever, but get yourselves facile with the Doppler effect. What do I mean when I say case? What I mean is here, it sort of walks you through, it gives you a couple of numbers, which are good numbers, right? But it has the car moving away from you, and it has the car being the thing making the noise, right? And it ultimately asks you it has the car making a noise of frequency 500 hertz. It's ultimately asking you what frequency you will hear when this car is moving away from you and making a sound that it hears as 500 hertz. Like, so I'm going to tell you two things right now, and then I see there's something in the chat. I'll look in the chat in 1 second, but I'm going to tell you a couple things right now. Like, in order to, and we'll go over answers next week, by the way. Also, that's why we're doing this now, is whatever questions you have about answers and stuff, we'll talk about next week in our last class. But I wish, I sure hope we have. Oh yeah, of course. Yeah, we do. Okay. I'm going to tell you right now, first of all, if in this case, it doesn't matter, call it, this is a case of source receding, right? Because the car is the thing making the sound, and it's moving away from you as you listen to the sound. So this is a case of source receding. The answer you're going to get to these numbers, if you've been following with me along in the class, you're going to get an answer that's lower than 500. Like the right answer to this question, I'm not telling you literally the answer just yet, but I would think, would get an answer that's less than 500. What I encourage you to do is, before you even move on to anything else in the test, practice and shift gear after you get an answer, even though the question doesn't say it right here. I'm warning you, I'm telling you, I'm suggesting. Then try what would happen if the car were moving toward you. Get an answer, like you'll get an answer that's greater than 500, and it should be greater than 500 by the same amount that your original answer is lower than 500. But then I'm telling you, you should try using those exact same numbers, but switching it so that it's you that's moving away from and toward rather than the car. And I'm telling you right now, if you're following me, and again, we'll go over this, but I'm telling you right now that if you then switch it to do like cases 3 and 4, and if you're the one moving away from the car and then toward the car, again, sure, you'll get two answers that are lower than 500 and greater than 500, but they shouldn't be the exact same answers that you got in the first two cases. This is really what I mean by practicing the Doppler effect, is seeing the different cases. If you did nothing else today, it would still be really valuable. If you just took this problem here that happens to be asking about one case, like what I'm really saying is on your actual exam, I don't know which one's going to be. And honestly, it's going to be more than one case. It will be. So you should know how to do any of the 4 cases. Then I'm going to say one more thing, and then I'll go on. I will look in the chat, and then I'll stop. Don't forget that we really got involved in about 3 weeks ago, and it's a little tricky, but if you really want to challenge yourself, or you really want to be prepared, whether it's for the actual exam or for optional points or whatever, then you would want to try, what if you use all the same numbers, but you pretend that instead of it's a wave coming out at a frequency of 500 hertz, pretend that it's a bunch of little particles coming out 500 particles per second. Do the same numbers, same combinations, And again, you should get something not identical. That would, if you can do all those like 6 different possibilities, then you really know the difference between waves and particles, which honestly is really the theme throughout like everything we're doing on this exam and in this course. It's all about stuff moving through space versus information, not stuff moving through space. And the more we can really see the very subtle mathematical distinctions between the two, the more we see how it is that we view our universe and how we ultimately understand electricity, magnetism, sound, and light and heat as they propagate immaterially through the universe. Like that's really what we're trying to put together here. Okay, so I will look at the chat. I will really try to shut myself up. Believe me, I need the time to work. But what I'm really trying to say is the very first, even if you don't even go any further, the very first problem on this exam is a Doppler effect problem. It's only asking you for one case, but it's kind of random which case it's asking you. If you really want to know what's going on, and again, you could split into groups if you want, but play and see all the different cases. I'm going to go on, but let me just look in the chat for a second. Sorry. Oh, actually, I will. All right. I am glad that Yulia. All right, so Yulia did just report in the chat about the first case of Omicron variant, and I do. All right, yeah, that is, that's certainly very real and very relevant, and I appreciate that, Yulia. And I'm not going to do anything about it right now. I mean,
that is just for the information. So
yeah, no, and that is, and yeah, no. So thank you for sharing, and that sucks. Of course, I think it was yes, no, thank you for sharing that. Obviously, this is the world we're living in now. And that is more important than, but I don't know what to do with it. So yeah, but everybody yeah. I mean, we knew this was going to happen, right? I mean, I'm not minimizing it, but anyway, I've got, someday if I all meet you guys in better circumstances, we'll talk spiritually about all this, but yeah. Yeah, no, that sucks. I wish I had something helpful to say about that. I certainly don't think that that's irrelevant. I mean, you know what I mean. All right. Now, the next page, to be honest, is a summary of what I just said. Sorry, what I just said, I will try to say next week. I'm just saying, part of what I'm saying has to do with details that you've really investigated in detail this semester. And part of it I'm rushing through and just saying, like, and I appreciate that Kazi, I mean, is being nice to even say that she appreciates the larger story. I mean, this course is supposed to be a story, not a fictional story, but a story of reality, a story of how physicists understand the universe, or it's supposed to be a courtroom drama, whatever. Obviously, we're getting sort of, it's hard to tell the story in the middle of COVID on Zoom in limited time. Like there are certain chapters of the story that we're doing much faster than others, as you can tell. I am racing through certain dots that I'm connecting in this whole thing. But really this page right here is making sure that you understand the skeleton of the story, of the point of this course. The point of this course is to understand enough about the propagation of raw information that you could come to understand why physicists at least believe that we're living in an expanding universe. Okay, I mean, so I think, yeah, I'm not going to tell you the answers right now, but this page, if you're looking for how to answer it or where the answers come from, they basically come from the recording of what I just said. And I think I also said something very much like it 2 weeks ago or 3 weeks ago or something. But yeah, so I'm going to leave it. But you mean oh, sorry. Okay, Yulia. Yes, please. I'm sorry. Yes.
Yeah, for example, for part 2 of the practice exam or regular exam, how do you apply the 5-step process to answer these questions?
Oh, right. No, great question. Great question. For this kind of thing, you can't. You don't. It's
Okay.
totally a fair question. And also what Hannah asked before was a fair. For this kind of stuff, you just do it. You just answer in as clear English. Oh, in fact, for this one right here, I'm sorry. For this one, it's like actually short answers. Look, I'll even tell you. Wait, I think I can. Sorry. Okay, you know what? I'm going to just tell you the answers to these right now. If you're paying attention, you're absolutely right. Like only the actual problem solving, the quantitative problem solving portions can be done with those 5-step method. This is trying to put things together. So I think I can even tell you this quickly right now because I'm not trying to mess you up. Okay. All right. All right. The answer to the very first question, I will tell you right now. And I'm telling you, when I say I'm telling you right now, I mean, I'm saying it because it's true. And because it is the answer to this question, you haven't heard it before in this class. I'm telling you right now, because I want you to know the answer to the first question is called Hubble's law, as in the Hubble telescope. Okay. Hubble's law is, in fact, well, if I screen, it's the thing that was on the very first screen. I mean, the very first page of the screen before I switched the screen sharing. Okay, write this down as long as we're okay. Write down as the answer for number one. And so anybody who's here today, you're basically being tested on whether you were here and paying attention today, I guess. But the answer to number one is V equals capital H times lowercase d. I'll explain that. Let me just say it again. I wonder if I can even, I think I can. And I know there's more stuff in the chat. Let me just see if I can do this. Hold on one second. Can I do this? Yeah, I don't know if you can see that, and I don't know why. Okay. This is what I'm writing. And I'm telling you right now, for the first time, like this is we're going in kind of a funny order, but I just want you to know everything that you can know before the course ends. And I never spell Hubble. You might have to look up. I never spell Hubble correctly. I have a thing with spelling it correctly. I don't know why. But Hubble's law says V equals HD, where V stands for velocity, capital H stands for something called Hubble's constant, D stands for distance. And again, I'm just telling you this right now. And again, to answer Yulia's question and Hannah's from before, you can't apply the 5-step method to this type of question. This is just like a knowledge thing. But what I'm saying is, according to Hubble, the universe expands in this following way. If D stands for distance and V stands for velocity and H stands for Hubble's constant, what it turns out is the farther away a star is, the faster rate at which it appears to be moving away from us. That is a conclusion that data has led us to. Like, I'm not saying that's obvious at all. I'm not saying that that directly follows from Doppler effect. I'm saying that due to the Doppler effect, due to our ability to infer from frequency shifts the rate at which stars are moving away, it turns out we can put together this enormous amount of data, or Hubble in particular, put together this enormous amount of astronomical data and came to a finding that, oh my gosh, not only are stars moving away from us, but it appears that the farther away a star is, the faster rate at which it is moving away from us. I'm telling you this now because here we are. This is why we're here, to go over this stuff. And basically because Yulia just asked or whatever, because there it is on the page. I mean, I might not have told you this until next week under other circumstances, but I'm just telling you, it turns out that Doppler effect data leads us to see that farther away stars are moving away from us faster. Now that is the real meaning of expansion. Like that means the universe is really spreading out in the manner of a balloon being blown up. Like it's not just that things are moving, it's that they're moving more and more the farther and farther farther away they are from us. I am literally not, and as long as I'm being asked and I'm just trying to teach you something, I just want you to know. And again, if you're thinking, well, wait, do I just spit this back on the final exam? Yes. Like I just want us all to know this, basically because I'm like taking Kazi at her word that this stuff is just damn interesting. And it's like worth knowing. Like it's, and you're all smart enough to just like know it. So I'm telling you, But by the way, like, why would anybody believe this? There's no it's so weird if you really think about what I'm saying. Now I'm getting myself all excited, and I know I have to look at the chat, and I know I have to shut up. But look, there's this thing called Hubble's law, which is the answer to one. Hubble's law, when you really start thinking about it, and you really start thinking that we're saying the universe is spreading out, that space itself, the totality of it, is getting bigger. That is such a crazy idea. That is such a crazy idea that really there is no reason to believe it unless you have reason to believe it. Like, I am not trying to argue that it's just logical that we would think that the universe is expanding. It's not just logical. It's logical as a set of inferences from other things that are logical, that are a set of inferences from experiments we do. This is why, in a way, again, this whole order of the course, like the motion that you do each week. Remember, we started with these like seemingly sort of dumb, self-evident kind of like a spring exerts a greater force the more you pull apart the spring, and then from the spring we go to harmonic oscillation, and from a harmonic oscillation we go to a collective oscillation of many, and then it makes a medium, and then makes a wave pulse. What we're trying to show you in the course is that if you go bit by bit with each sort of basic inference that we make from basic lab data, you get a set of statements or inferences that together bring us to very crazy conclusions that are crazy enough that we really should not just accept them unless we had worked through all of the building blocks. Okay, so anyway, I'm going to look in the chat. I'm saying the answer to number one is Hubble's law. That's the observation that light from distant stars leads to outer space spreading out. By the way, also, if you believe that the universe is spreading out, that means if it's spreading out in time, if you just make a movie in your mind of a universe that's getting bigger and bigger, if you think of that as one big movie, well, if you run the movie backwards, if you go back in time in your head, that means you go back to a smaller and smaller universe in your mind. If you go back far enough, you're going to get to the point where the universe was just a point. That's the notion of the Big Bang. The reason we believe in a Big Bang is just because we've run this movie of the expanding universe backwards in our mind. Like, what we think of the universe is exploding because of this. It's not because we want to. In fact, we don't want to. It's like very weird. But wait, all right. I'm totally going to look at the chat. I promise. I see there's 7 things in the chat. I feel like I'm doing a disservice if I'm like all over the place. So let me number 2, according to a phenomenon commonly referred to as the redshift, starlight frequencies measured from the Earth's frame of reference tend to suggest a shift toward the red end of the spectrum. In comparison to what? Okay, in comparison to what? In comparison to the frequencies as measured from the star frame of reference. Like, just like the Doppler effect. Okay, I'm just telling you so that so we can get this sort of clear. In comparison to the frequencies as measured by the star frame of reference. Indicating what? Indicating that the stars are moving away from us. That's the answer to that. Put it in your own words, but that's what I'm saying. Again, I will go to the chat. Let me just get through this page so that I've done you some kind of service. And again, remember, this is pretty much your exam. I'm kind of like walking through the exam right now with you, or at least the parts of it that I can. So anybody who's in class today is doing a good thing. The term redshift is associated with so I'm looking at number 3. The term redshift is associated with the particular application to light of a more general physics phenomenon. The general phenomenon entails wave motion from one reference frame to another. This more general wave phenomenon is known as the Doppler effect. You see, so what we're doing here is we're just trying to bring you from the punchline of the story down deep to the axioms of the story. We're trying to make sure we're sort of walking through the story backwards on the sheet to make sure that you get it. The conclusion of the story, the top 1 question is like what you hear about in the New York Times all the time. What we're trying to do is say essentially why, and make sure that you get all the becauses to all those whys. So that's number 3 is the Doppler effect. Number 4, only wave motions such as tides or sounds can experience a Doppler effect. What evidence or reason do we have for considering light beams to be some sort of wave motion? Okay, I'm going to tell you the answer to this right now too, because I don't know that you've done it yet with Walters. It's usually one of the very last labs we do, and I know time has been squeezed, in our COVID Zoom life here. So, and I don't want to give away his fun, but just in case, I'll just tell you the conclusion, and I will look in the chat. I promise. I see that the chat is going crazy. The chat's probably saying we can't even hear you or something embarrassing like that. But I'm too worried that if I look in the chat, I'll get really distracted. So let me just say, number 4, I'll tell you the words to the answer, but you want to look out for this when you have Walters next week. Also, let me say, I communicate with Walters. So like, if he doesn't get to something or something, I'll know that and we'll adjust the test accordingly. That's why this is a rough draft. Okay. But the answer to number 4, what evidence or reason do you have for considering beams of light to be some sort of wave motion? The answer is double slit interference or two-slit interference. When light goes through two slits, it interferes in the manner of sound or of water waves. That's all I'm going to say on that for the moment. I might have mentioned it before. I think Walters will talk about it with you. I think you've heard that in other classes, but I'm just saying for the moment. We would not believe that light was a wave, or we wouldn't have confidence that light can behave like a wave, were it not for this thing called the Two-Slit Experiment, which was first investigated in a quantitative, convincing way in 1809 by Thomas Young. Okay, now that there's 2 hands up, I really better look in the chat. Hold on, I'm going to get the hands, but now I know, yes, I'm sure something crazy is happening in the chat. You probably didn't hear a word. All right, let's see. Oh, wow, you guys, oh, wait, no, this, oh my God, wait, the chat looks great. Hold on, and I don't totally see that the hands are up. I'm just freaking myself out, so hold on a second. Let me, okay. Oh, didn't I type it on the screen? Oh, sorry. Okay, well, wait. All right, so Hubble's, all right, I'm looking at the chat now. I'm sorry, I go. Okay, so Shasha, okay, Shasha is upset about the variant, fair enough. Can you type in the chat? So thank you, Kazi. I thought I had typed it. I thought I had edited, but I guess I didn't. But yes, what Kazi put is correct. Hubble's law, V equals capital HV. Thank you, Kazi. I totally appreciate it. That is the answer to number 1. I thought I tried to annotate it on the screen, but I guess it didn't work. So thank you, Kazi, and thank you, Kwan, for thank you, Shasha, for asking. Thank you, Kwan, for thanking Kazi. Okay, and thank you, Shasha, for thanking. Thank you, Diana. Sorry. Okay. Then Yulia. Okay. Oh, yes. And so light can demonstrate wave. Oh, you guys are so with me. This is so good. It really does inspire confidence. It makes me just want to just give you all A's right now, which you're going to get. And they're not gifts. I'm not giving them. I'm just recording them. Because yes, Kazi's right. Light can demonstrate wave characteristics. Absolutely. And oh, thank you for saying that. I discussed it earlier. Good. And yes, Kwan, awesome. Right. The way that we know that light can behave like a wave is in a thing called two-slit interference, or you could call it double slit interference. You can call it Thomas Young, like Y-O-U-N-G, Thomas Young's two-slit interference experiment from the year 1809. I probably should type this in the chat, but that's exactly right. And believe me, I'm very tempted right now because you guys are so with me, it seems. I'm very tempted to like go into a whole discussion of that right now, but I don't. But I think you're going to do that with Walters, and I think that will just like confuse us. So I won't. I also think there's a picture of my ceiling in the middle of this Zoom thing. I should probably turn. Okay, so now can I repeat the answer of number 2? Number 2. What was number 2? Number 2. So the answer to number 2 is
Doppler's effect, you said?
Yeah. Wait. Well, the answer to number 3 is Doppler effect. Yeah, like the more general.
I wrote the answer for number 2 in the chat.
Oh, sorry. Oh, I should really catch up. I'm sorry. Okay, thank you. And that was okay. Thank you. Wait. Oh yes, right. Well, Kazi. Oh, great. Thank you, Kazi. Yes, what Kazi wrote is the answer for number 2. What Yulia wrote is really forgive me, but is really the answer to number 3, if that makes sense. And what Kazi wrote in the chat is the answer for number 2, if that makes sense. Oh, I think I'm caught. Are we? But no, I really, guys, honestly, this is where, and you don't forget, for whatever it's worth, you can all like put these in for the closing a conversation and double team, like multiplayer. Like you should all get points for all this, but much more important. I don't even think you need the points at this point, but karmically, I just want to register it again. You got, there's so much talk in the faculty and administration. I'm on so many committees at John Jay about online learning and like what's happening with it. And is it a disaster? And what's the future about? And I just want you to know, you guys restore such faith in me that it is possible for people. You really are with me. I mean, it's clear to me, I believe, and I really appreciate that. as a teacher and as a human being. Like I like, it's just so clear from what you're doing in the chat that you are here. So thank you. And again, it just makes, I hope it's clear that I also see that, and I want your grades to reflect exactly this level of engagement that you have. Okay, right. So then the answer to number 4. So I think we're good, right? Or tell me in the chat. So, and I am looking at the chat, but I think we're good with this sheet. Like, I think we've just answered number 1 through 4. The number 5 is a little bit silly, but oh, a comment. Okay, please go. Yeah. Oh, that's right. You had your hands up. I'm sorry. Go. Yes. And also Yulia after that, if you also. Yes, go, Kazi. Sorry.
So you said that Professor Walters might like go over this in detail in the next class. I'm not sure if he told you, but he told us yesterday that what he wants to do is he wants to review all the information from the semester.
Okay, which is great, which means, okay, and I will probably check it with him tonight. No, and I was hoping that, wait, he wants to do that too. Oh, I keep saying tomorrow. Of course, I mean next Tuesday. Right. Okay. No,
He said if we get a packet, the review packet, which we did today, he said he will help. Like, I don't know. He said we're gonna go over something. Yeah.
good. Okay, so that's perfect. So look, I mean, so wait, oh yeah, so this is the review sheet. I mean, this is that sheet, right? I mean, so we are actually, believe it or not, on the same page. We're very like he wanted to make sure that you got one from me, and here it is. So this is what he, and I'm just getting a head start on it now in a way. It also, yeah, no, this is great. I mean, this is the sheet that he was maybe worried that I would forget to give you or something, because that's happened. Or more likely, anyway, so this is it. So he will, yeah, I mean, the truth is he was probably worried that I didn't know what week we were in, because that often does happen. So yeah, I mean, that has happened. So but anyway, this is exactly the thing that he was hoping that I would give you. So here it is. He probably assumed I would just give it to you right at the end, and then he would have to cold walk through it with you. But we're getting a head start here that I'm walking it through with you. And I will, again, stop talking. But basically, we all here have a day jump. Like we're actually bizarrely ahead of the game a little bit. Probably because honestly, both of us are so always afraid that we're behind, especially with COVID and all of that, or we're just afraid that we're going to mess you guys up. So basically you're getting a couple today and next Tuesday to review all this. What I'm going to ask you is I'm going to ask you to throw back at him, since we are getting a bit of a head start here, and we're walking through it. Obviously, be honest with him and let him know that you started walking through it already, so you won't be shocked when you open it with him. But I will ask you to ask him to go into a bit of detail over two-slit interference. Okay, however he wants. Usually there's a whole lab on that. Maybe there isn't time for that this semester, and I understand that. But and again, if we get time, I will. But usually that's something that happens in lab. So if you could just alert him that we're already doing a lot of the walkthrough together as a group. But if he could reinforce the two-slit, I'm not asking. This is like mommy says, daddy says. I'm not asking you to do like go bowling with him every other Sunday and then come back to me for your allowance. Like I'm not, but and I will talk to him, but I hope it's clear. But I am saying, and again, remember, I'm also doing this partly now so that by the time we all see each other for our last class next Wednesday, we'll all know whatever loose ends there are that you're concerned about, and you'll be able to ask me then. So if by next Wednesday, this is still the practice document sitting there and you still don't understand two-slit, you're going to tell me, and we're going to talk about it then, if that makes sense. But yeah, but this is the thing. This is the document he has been talking, if that makes sense. Okay, because that's what happened. Okay. Okay. So, okay, this last question is a little bit silly, but this is a little bit silly. I mean, it's a little bit cutesy, but basically we're just trying to get at here, question 5, like, what is a thing? A particle is a thing. I mean, again, this is a little bit cute. I don't think we've ever taken off any points for this question on anybody. We're just sort of trying to see what you would say. But what we're trying to get at here is like a particle is a thing. What is not a thing? Well, like justice is not a thing. Love is not a thing. I mean, of course, they all exist, but this is just silly. You can answer this any way you want, but what is a not thing would be something like sound or heat or electric current or light. Like what we really mean by this is what's the difference between a particle and a bit of information. A baseball is like a particle. An electron is a particle. A planet is a particle. A light beam or a sound wave or an electrical current, these are not particles. These are packages of information or flows of energy or some other abstract word that you may want to use. Some things that move through space are material, some things are not. That's all we're trying to get at here. And I will say, and then I do see there's more in the chat, but what is it now? But I promise you won't lose. If we had this exact question on your exam, it's meant to be cute and fun. Like people don't lose points for this. But on the 1, 2, 3, 4 choices, honestly, what's the correct? Like it says which is farthest from false, which means which is like the most true. The real true statement of those 4. What we again, and I apologize, we're being a little bit overly clever and overly cute here in number 5, but of those 4 choices where it says which of the following is farthest from false, meaning which is like the most true, I honestly, I would say that the answer is it's really 2 is really the most true, or possibly 3, because what we're really saying there is space. If space is the stuff between things, the amount of space is getting bigger in the universe. Now, and if you dissect those different possible answers, I think 2 or possibly 3 is really the most true, but don't like get yourself stressed over this question. If you think that the question is worded in a very mind-bending kind of messed up way, yes, it is, because we're sort of trying to get you to realize that when you really think about the universe, even if you think about it in the most mathematically rigorous, precise scientific way, if you think about it enough, eventually one's mind does become very, very bent over thinking about the bending of the universe. Like the truth that we're trying to get with you guys is the universe is fun and wacky, like even when, or especially when you're super scientific about it. Like again, so don't stress about question number 5. No one ever loses points on question number 5. It's just, and our version of it might be different on your exam. It's just a bit of silliness, but we really are trying to say honestly that the more you actually rigorously think about the nature of space, time, and motion, the more your mind should feel a lot of motion sickness, because it is weird. Whatever conclusions we come to, even the most mathematical and the most experimental, the conclusions we come to about the universe are not the ones we would expect going in. And that's from science, not from fantasy. Okay, let me just look in the chat. I know I'm talking so much. Okay. I'm going back to the chat. Oh, wait, you can't download. Wait, Noreen. Well, maybe I should read all the chat before you are having problems downloading this document from the Google Classroom. It should be downloaded. Wait. Yeah, it should just be a PDF it's certainly meant to be for your, it's meant for you. We mean for you to be able to download and print it. So I'm looking at, did other people, I see that Yulia says that she was able to. Oh yeah, you're right. You have to open in a new window. Thank you, Kazi. That's totally the point. Yes. Try that, please, Noreen. That's right. You have to like open in a new window, then you can do stuff. That's so weird, but that's totally the deal. Thank you, Kazi. So try. And can a wave be a thing? Kwan, great question. And again, we're sort of playing with language in a silly way here, but the way we use the words, look, waves definitely exist. Waves are real. They are part of science. But the way we're talking here in this course, a wave is not a thing in the way that a particle is a thing. If by thing, and this goes back to the beginning of the course, like thingy thing versus unthingy thing, again, those are silly words, but we're really trying to distinguish in this course. We're making a distinction between particle motion and wave motion, when a wave moves from here to there, there is no individual, identifiable, countable, discrete, particular, bounded, or material particle that goes from here to here. In other words, ultimately, I'm saying and Kwan's question is great. I mean, because I know I'm getting all crazy, but Kwan's question is like the point. And ultimately, I'm saying to Kwan's, let me be clear. Kwan is saying in the chat, can wave be a thing? Ultimately, by the definitions we're using in this class, I say no. A wave is not a thing. If by thing we mean particle, if we mean countable, material, discrete, locatable, identifiable, maybe I already said that, bounded object, a wave is not that. A wave is not a thing in the way that an electron or a planet or a baseball or a car is a thing. A wave is not. Like, and I'm saying this to everybody. Now, again, language is funny. Honestly, one of the reasons I love math so much and Walters loves math so much is ultimately, once you do enough math, you sort of get out of some of these English fuzzinesses. Some of this fuzziness comes from English. So, I mean, let me put it this way. I'm not saying waves don't exist. They do exist. And not only do they exist, but they're observable and measurable and analyzable. They're part of science. They're very real, but they're not things. Same way, like justice, I think exists, right, in other courses, not in science, but like justice is like part of the world. It's part of the political world. It's part of our society, I hope. Or maybe if you think it's not, maybe injustice is, right? Or love exists, I hope, in your home. I hope there is love. And if there's not, maybe there's hate, right? I hope there's not. But those things exist, but they're not things, right? Like they don't occupy space and time one at a time in the way that things do. When we say thing in this course, we mean particle. I think the last thing I'll say is, by which we mean something that occupies one space at one time, cannot occupy two spaces at one time, and cannot occupy one space at one time with another particle. That's what we mean by a particle or a thing in this course. And electrons are those, protons are those, baseballs are those, but waves are not, and electrical currents are not, and electrical fields are not. And that's why we spend so much time studying them in this course. I hope that makes sense. But again, I'm yelling, not because I'm angry at all, but because Kwan's question is like the question of the whole thing. Like this is, we are here studying the motion of not things. And if you're hearing me more and more, if you're getting the point of this course, what you're getting is that we're sitting here saying that there's motion of not things that's totally real and totally important. Like ultimately, the way we understand the universe is through things like sound and heat and light. These are not things. These are propagations of informations. It's very, very, the material universe is best understood through its immaterial components. That's what we're really trying to get across in this course. And that's what we're trying to test you on in this document. And as long as everybody gets that and maybe finds it a little bit interesting, then everybody gets an A. Okay. Okay. Oh, cool. Oh, okay, cool. All right. So I'm going back to the, okay. If you open a new window, but I really should shut up so that you can practice, but okay. Can wave be a thing? Okay. Thank you so much. I got it. Great. Okay. So Noreen's got that. What was, C? Oh, what was C? Oh, in question 5. Oh, what is not? Well, according to the silly way I'm talking about, so an example of a not thing would be like a sound wave or a heat wave or an electrical current or electrical field. Like those would be not things, but don't over worry about question 5 because it is a little bit just silly. Okay. Okay. Yeah. Kazi's right. Yeah. Okay. Yeah, exactly. Thank you, Kazi. Okay. I should really read the whole chat before. Okay. So good. Okay. So you guys are good. I'm just looking at the chat. Good download. Okay. Kazi, help me. Okay. Cool. Yes. Right. Exactly. Like the first one. Yes. Kwan, you want to comment? I'm sorry. Kwan, go.
I'm sorry, but can you differentiate between not a thing and a nothing?
I mean, that's a very fair question. That is a good question. Again, maybe I'm being a little bit silly there, but I think honestly, what I'm saying there is like, what is not a thing would be like justice or love or hate or something super abstract that doesn't even occupy space or time at all. Like justice and love, they're real, but they don't even live in space and time. They just live somehow. But a not thing would be something that does live in space and time, but in this non-particular way, like heat or sound or light. So answer to B would be like justice or love. Answer to C would be like heat or sound or light. That's okay. Yeah. Okay. But it is a little, don't over worry about it. It's a little bit silly. But yeah, that's okay. Okay. So that's that. Now, the rest of the test, or again, let me warn you, the reason we just spent all that time in a way that the rest of the test tries to put together everything you did. And again, Walters will walk with you through this on Tuesday. I'm going to give you a brief overview of this rest of this, and then you're going to start practicing. What happens in this next part 3, you get a bunch of weird questions. I know they're like tilted in a funny way. There's kind of a reason for that. And they're labeled in a funny way, like TAU. We might change that. That's a little bit confusing. It's not meant to be, but the point is you have these fragments for this part 2. You have like this honky tonk man in a Honda, blah, blah. Can you see? Yeah, you can see. And that's like section T. Then section A is sitting at the origin on some tiny number line, blah, blah, blah. And then there's this other fragment U when the first dolphin. Now, what's going on with these fragments? All you're being asked to do in your first pass through of this test is read the fragment and literally simply write down whether it's true or false. You don't have to justify anything yet. You don't have to solve any problem yet. You don't have to really even show any work. Just the first time you go through this, when on the actual exam, you're literally just going to say T or F. Now, so it's more about reading than writing. You're going to have to read them. Okay. The reason that they're all funny, we didn't mean to make it hard, but the reason they're like funny fragments like this, and the reason they're odd, because they're intentionally out of order. The point is they're meant to be fragments of material from this course that are not necessarily in any order. They're just fragments of material from the course. Some of them are about the Doppler effect. Again, like you really want to know your Doppler effect, but some of them like number 1 is about the Doppler effect. Number 2 is about electric fields that you just started learning about 2 weeks ago or 3 weeks ago, right? Then I don't mean number 2, I mean like A is about electric field. Then on the next page, that one, number U, is about simple harmonic motion, about a pendulum, going back to the beginning of the course. Same with V, the next one. Then W is about a circuit. Okay, so these are fragments. This is why it's a final exam. These are fragments. They're much more about reading carefully than writing anything down. You're literally, but each one of them is a little scenario, and you just simply write whether true or false, meaning this could have happened, like this makes sense, yes, whatever the paragraph says, or no, it doesn't make sense. That would not be, like, given those facts, that would not be the conclusion. Like whatever it is, you're back in that courtroom sort of. You're just literally saying whether they're true or false. And again, this is the kind of thing you're gonna, when I finally shut up today, because we do still have an hour and 10 minutes, right? When I finally shut up and just release you and you're practicing, I hope you'll stay. I mean, you will stay, but you can divide and conquer. You can divide yourself into groups, and like somebody can practice a Doppler effect and somebody can start working on some of these or whatever you want. But I'm telling you, you certainly can and should discuss them with one another. All you're trying to do for these is just say true or false. So it's much more about careful reading comprehension than anything else. You just say true or false the first time you go through. Okay, so I'm not going to go through them. And occasionally you might see one that you don't recognize yet. Like I'll tell you right now, number I, if you see it, the one on the bottom of the page that you're looking at right now, the bottom one, thin column of light with wavelet, blah, blah, blah. That's about the two-slit experiment. You might not really be able to answer it right now. Maybe you'll try. Maybe you can remember from another class. But that would be the kind of thing, if you still, by Tuesday, if you're still confused about that, definitely ask Walters about that one. And that will give him an opportunity to give you a brief overview of the two-slit experiment, how it works. Other than that, just about everyone I'm looking at so far, I think you can answer with the material that you've gotten so far in the course. Okay, so they're and like number X you would have never heard about before, but I just told you today, I'm telling you right now, X is about this Hubble's law business. And all that I've said about it so far is enough information to answer that. You just need to know about Hubble's law, that the farther away things are, the faster they're moving away from us. V equals HD. It's a shockingly simple law. And H is just a constant, a proportionality. It's like if you made a graph, it would be, V would be, it would be a straight line graph. V would be the y-axis, D would be the x-axis, and H would be the slope of that straight line. So these then like Y is a Doppler effect, or Y is like about waves. So all of these are just about different things that you've done in the course. You just have to say true or false, okay? And again, this is how your real exam will be. Maybe we'll change. Well, hopefully we'll make it maybe a little bit more readable. It's not, but that's the deal. You just say true or false. Then in the next section, it goes back to those fragments that you just answered. And again, they're labeled in a funny way just to reinforce that they're not in any particular order. And by the way, you shouldn't do them in any particular, just do them in any order that works for you. But it now asks you to go back and answer a question about them. Like A, it says, if true, then add one more electron to the same location as first and calculate the new E field. Or if it was false, find the correct position of the electron. So now, for this section, you're solving problems. You're taking the problem based from that little fragment and you're solving it. It's like one or two little representative problems from each bit of material we've done in the course. It's not a whole exploration. It's just like a little problem to represent. This is where, please make a note, this section 4, like this is where Hannah was asking before and Yulia was asking before and maybe other people. This is where you want to sort of show your work and show a 5-step method. You want to like justify your work here. Now, again, you're going to have most of these questions in advance and you're going to be taking this home and doing it on your own time. Open universe. You totally can work together, even in the actual final exam period. Okay, there's no concept of cheating here. Like anything you do is not, nothing is cheating because we're saying you can do anything and everything. But therefore, for this section in particular, to answer the question of Hannah and Yulia, this is where you really show that you understand. You can all help each other understand it. But once you get what you think are the right answers to this, then really show us that on your particular exam document. Like this is where you would show all your work, show a 5-step method. You know what I'm saying? Like show that you're not just copying from your friend here. You can get the help from your friend, but that means they helped you to understand, not help you just regurgitate. Okay. And of course you can go to Khan Academy or whatever else. Okay. So I'm just, again, this is like a walkthrough of how the test works. And then finally, and this is the hardest part probably right here. Like this is where, you solve those problems, but that's it. It's that many, like 10 problems. And again, this is why the whole thing looks like it's 11 pages because it's all this funny format, but it's really not that much that you have to do. Then, well, I guess it's somewhat. Then you take each one of those items, okay? Each one of these like V, X, P, Y in part 5. You take each item and you literally just write out a sentence. This is also where you can practice with Walters on Tuesday. Because again, I'm warning you now how this all works. So ideally between now and Tuesday, you practice this on your own. And again, starting in 5 minutes in this period, you will practice on your own. You will help each other. But on Tuesday with Walters, you can ask him for examples here, or whether you're right or wrong or whatever. But for this part here that I think you see on your screen, for number 5, you take each one of those little things and you just make a statement of truth, like a motion type of thing out of that example. I will give you one example right now of what I mean. I hope I'm not going too fast. I am watching the clock. Like say you go to, say I'm just making sure on my screen that you could see. So I'm looking at X, right? In X, a galaxy known as galaxy norm. Now, again, this is an example of something we just said today. So hopefully this helps you follow what I'm saying today. But in that example, first in the early section of the exam, you said whether it's true or false. You just literally said it's true or it's false. Then you were asked a little numerical question about it, right? And now you're just supposed to look at it and say, in summary, like, what's the point of this? Like, what's the takeaway? The takeaway is the farther away galaxies are from Earth, the faster rate at which they move away from Earth. I'll say that again. And that's not perfect, but the farther away a galaxy is from Earth, the greater rate at which it moves away from Earth. I'll say that one more time. I'm looking at X right now. I'm looking at excerpt X. The farther away a galaxy is from Earth, the greater the rate at which it moves away from Earth. You would write that sentence down. It doesn't have to be those exact words. I just said those words right now, but words like that. A clear, declarative, specific sentence that captures the basic point of this finding. Think of it as a basic plank in a larger argument. If you always keep your eye on the prize of this whole thing is that we're trying to convince ourselves that the universe is expanding. Honestly, again, that's the purpose of the whole course. I mean, not well, yeah, that's like the final objective of the whole course is to have some understanding of why people believe the universe expands. By the way, you could walk away from this course and still not believe that. I mean, in fact, all the power to you. After this whole course, you could get an A in this course. You could get 100 on this exam and walk away and still think like, okay, now I've seen all this. I think it's garbage. I mean, I think that's BS. Like, I think that's like the stupidest argument ever. God bless you if you like, because at least then you know what the argument is. And now as an educated person, you are coming to your conclusion that you think that's totally fine. We just want in this course for you to actually understand enough to be able to come to a reasoned view on your own. Unlike most people who just read the New York Times or whatever, just like, oh, the expanding universe, blah, blah. Oh, the Big Bang, blah, blah. And they have like no idea, right? I mean, so if you remember that the purpose of this course is to get you through all of these planks to finally see why we believe the universe is expanding, always bear that in mind. When we ask you to translate each one of these little fragments into one sentence, just try to think of a sentence that puts this into the perspective of that larger chain of reasoning. Do you follow me? I mean, hopefully you follow me. So the example for this one would be like the farther away a galaxy is from Earth, the faster rate at which it moves away from Earth. That's a statement that we believe in this course. It's like a motion that comes from things before and leads to things after. You don't have to prove that that's true. You just have to make the English statement. And it's, of course, not going to be anybody's exact words. We all have different words, but they have to be good words and they should be your words. Okay, so that's what so you would do that for each one of your little fragments that you did. And then so that's 5, right? Okay, so I'm scrolling back where it says 5, replace each item with one clear true statement. That's what we mean. You're going to do that. Then 6, I think this is just about yeah. And then here comes Hannah's thing in a way. Now it says, arrange the items in the best possible order to make a single argument. The argument ultimately advanced by the course material of Physics 102. So now in here, you're just going to take your statements and put them in order. And what do we mean by order? Well, we mean the logical order that goes from most self-evident to final conclusion. But what that really means, folks, is just the order of this class. We just mean put it in the order that, because that's the class was structured in that order. That's why we called everything a motion. Like it's like one big long court. We're basically putting the universe on trial and trying to prove in the end that the universe is guilty of expansion. I mean, if you like, okay? So each one of the little lab things that you prove true or false was like a little motion in those proceedings. So we're just asking you now that you've translated these maths into little sentences of English, put them in order that makes logical sense. And what that order is the order of the class. Hence, here you have, okay, right here on this sheet, this is the order of the motions that you got in the class, I believe, pretty much. I mean, he might have done it slightly differently. The very last one is the Hubble's law. I said H times D. You could, here it says H times R, same thing. You could write it either way. The one right before it, you might not recognize because that's the double slit experiment. Again, that's probably where to ask Walters to spend a lot of his time next Tuesday. But again, don't forget that then you'll see me the next day, Wednesday. So I can also fill in gap on that. But I think everything else there you recognize, and that's the order of the course. Those are the motions that you did in the course. Each one of those should that's just like a cheat sheet or whatever, like Hannah was asking about before. That's the motions of the course. Each one of those in some ways corresponds to a bit of English that we're asking you to put together. So hopefully you see all the little fragments you would have just done all somehow or other correspond to one of these things, or maybe more than one. And you're just trying to put them in order of this. This is the correct order. This is almost an answer just sitting there right in the middle of the exam. Okay, now there's one more page of the exam. That's the lab part. That is totally the Walters part. That's like to bring you directly to the motions. It's also just you'll see, well, okay, you'll see it's just like a spreadsheet to fill out. I mean, it's like a, what do you call it? Like matching thing. I mean, you're just going to put letter. He'll explain that. It is one more page. It makes this whole thing look very long. I realize. I'm going to back up and summarize that in a second, but this last thing is just a matching thing, and he'll explain that in lab. That's reviews the lab portion of the course. So now I'm going to take a breath in a moment. I'm going to stand back and say, Kazi is right. It's 11 pages. It just took me an hour to talk about. In a way, it looks like a very big thing. It is big in that it's about the whole universe, and it is some heady material. But if we stand back and look at this for a second, like many things in this course, it actually takes longer to talk about and to ask than it really does to answer. If we stand back and look at what this exam is, what we're asking you to do is do a practice. I'm going to scroll back and again, I'm going to shut up at some point. But on the first page, you're being asked to do a practice problem, kind of to get warmed up, but kind of to get to the meat of the whole thing. You're asked to do a practice Doppler effect problem. Then you've got a couple of fill-in questions, which I just told you the answers today. And I might or may not even, I don't know, I'll probably shorten this sheet. But then from there on, literally, you've got like 9, I think it's 9. 1, 2, 3, 4. All right, so it's like 10 or 11 true-false questions. Then you go back, look at the exact same questions, and you get numbers for them. So it's like 10 or 11 exercises, true, false, then problems to solve, then translate them into English, then put them into order, and then do the lab portion of the course. It's really 10 small exercises from various points in the course that we're asking you to show us that you understand numerically and verbally and all together as a whole. It is a funny exam. It's an unusual, perhaps, exercise, but I think it takes a lot longer to understand, scroll through, read, and discuss than it does to actually do, to be honest. But then that's also why we're taking all this time to walk you through it right now. Again, what it won't be is a surprise. You can view this whole exam as a project if you like, and you're totally going to get started on it in about 3 minutes when I finally shut up. And please remember, it's totally a group thing. Like this is never going to be closed book. It's never going to be under exam conditions. So it's a project. We just want you to take little fragments from all the way through the course and show us that you understand them both numerically and verbally, and then you understand how they fit together to make one large argument in the end. And the argument is that the universe is expanding. I've been watching you people. I've been with you people, and you can see I'm totally overjoyed and blown away. Every class, I sort of forget until we meet again how much you've been totally engaged, totally on it, and totally smart, like super smart, all of you. So I'm here to assure you that, again, it is true what Kazi say. It's 11 pages. That might look a little bit intimidating, but I think it is way. This whole thing is, I think if any group was positioned to be able to do a thing like this, to understand the trees and the forest, it's you guys. And it is not meant to trick you. It is meant to be what it is. So what I'm going to do now is say, first of all, I'm just going to see if it's sort of, I'm going to ask you in the chat to, well, in a minute, we're going to say, start working on it, start practicing. Either practice the Doppler effect problem at the beginning, or just randomly look for exercises. You know, you might want to just randomly pick one of the exercises, the truth, and see if you can say whether it's true or false, see if you can do the numbers, see if you could translate it to an English sentence. You might want to break up into groups, whatever. But I would say just try practicing this thing. Don't go in order of it. Go in the order that you want. And and definitely look first at things that you think you know. Don't let yourself get freaked out by looking at the things that you don't know yet. But just see if it makes sense. Because if you could do one fragment, then you can do all the fragments pretty much. So so we're not going to leave, but we're just going to work individually. And then, oh, by the way, you're going to jot down if you have confusions or issues or whatever, jot them down right now, but I'm going to ask you to jot them down and keep working together. I think today you're not going to, I think we've talked so much for the first hour and 15 minutes. I think for everybody's sake, for the next hour, whatever it is, hour and 10 minutes, I would strongly encourage that whatever questions you have, at least for the moment, like hold them, jot them down. I'm still here, I'm not going anywhere, but let's try to keep a record of what our confusions or concerns are for next week, because you still have all week to work on this, to also to ask Joe questions on Tuesday, blah, blah, blah. But this is what the final exam will be. So in the chat, can you just, or in voice, can you tell me, does it basically on the whole make sense what I'm saying?
I think at first, when I looked at it, I was just like, oh my God, it's so much. And now, like, as you explain everything, I feel like, oh, it makes a lot of sense. Like, it's not that bad as I looked at first.
It's the best thing I could possibly hear. I'm going to look at the chat. Well, actually, I'm going to respond to that. I'm so glad you just said that both. Oh, cool. Oh, wow. Oh my God. Oh my God. What? Okay. Either I love you guys so much, or well, I do, period. I do. But you guys are either like exactly as awesome as I think, or you're the most wise, clever ass kissers in the, and you're not, and even if you are, thank you. That's fine. I'll take it. But no, no, good. And listen, honestly, one of the reasons I'm so excited right now, first of all, I didn't even know that we would have this opportunity. And I think actually Walters was afraid we wouldn't too. I'm so glad we took this opportunity, but here, okay, cool. Listen, seriously, why I'm so excited. I feel the same way you do. Like, even you're telling me the perfect thing, all of you, by telling me on the one hand that it looked really scary. And I could tell, like what Kazi said, it scared me, what Kazi said at the beginning. I looked at it, I was like, oh my God, what am I trying to do these people? But now that we've all walked through it together, and of course we do this every semester. So I mean, it always does work out. But if you looked at it and you think it's overwhelming at first, but then now that we've walked through it, you feel like you're okay and you get it. And even God forbid that one of you even said it maybe almost looks fun. Then really mission totally accomplished already. Like, this is our ultimate fantasy and dream of this course. And I'm not saying it's never happened before. Before COVID, certainly, usually, like, we love to teach this course. It is our favorite course to teach, really. And it is like when it works. Now, sometimes it doesn't. But when we have a group like you guys, the ideal thing is that you look at it at first, it looks crazy, but then you get it. And then if you're saying what you're saying to me, I think you are gonna rock it. And please know too, if you looked at it and you thought it was overwhelming, but now you feel like it's okay and it'll be fun, which, by the way, that is true. It's really not that bad. Once, for anybody who's been paying attention, and you guys have so been paying attention, it really isn't that bad to do, and it kind of is fun. And here's the underlying secret of or whatever, for a group like you, if you realize that it does look bad and it seems crazy and it seems confusing and it's about the universe, but that it actually isn't, and that you actually can do it and you'll rock it, which you will, what that really secretly proves, or will have proven, is that you've actually really learned something here, right? Because the truth is, you're right. If I hand this document to anybody, even you guys at the beginning, it looks like a crazy document. Like, who could know this stuff or put it together or no? But the fact that you actually get that it's even not that bad at all means you really know something about the big questions of the big universe, and you know it in a detailed mathematical way. So I'm already commending you. I think the fact that you even have this attitude means you're like perfectly positioned. Oh, and Kazi missed the whole speech. Oh my God. Okay, but cool. No, I think you're going to be good. I think you will be good. And we have plenty of time to get this straightened out, right? We now have the rest of this class, like an hour. We have Tuesday with Walters, and then Wednesday. So we'll have this all straightened out. Like, we have 3 periods to make sure we're all totally good. By the time you go off to do this on your own time during final exam period, many of you might be practically done already, honestly. And that's great. Great. So I love your attitude in this, seriously. And I mean it. And even if you're just being nice, that's really cool. And we've had classes in the past that were not this nice. Okay, and good. If it makes, I'm just looking at the chat. Good. Okay, so I'm going to shut up. I'm
Wait, Professor, just
Sorry.
one more question. Just as a reminder, because we didn't do a lot of homework assignments, the 5-step process is like whatever is given, the question, what we're looking for, the diagram, and the solution and the answer, right?
Yeah, there you go. That's it.
Okay,
You got it.
just to make sure I don't forget something.
You're cool. That's awesome. And also, I know that too. I will also, when I'm grading these things, I totally understand what happened with our homework stuff this semester. So I will have that in my mind too. Every class is different. So I don't grade you according to what happened in some other world. I'll grade according to what actually happened in this class. So I understand what you're saying. So yeah, just show your work is the main thing. But yeah, you got it. Wait. Well, I think, Shasha, good question. Where you should draw diagrams, where would be really helpful. The place where you can be the most creative and the most thorough or the most detailed is specifically just in part, let me scroll back, just in what Yulia is asking about really is part, where'd it go? Yeah, in part 4 here, where it's actually asking you to solve the problems. That's where the more work you can show, including like a diagram, or including colors, including a little bit of explanation, like the more, that's the most open-ended part of this exam. The most like free response, blue booky part of this exam is really part 4. That's the part where like, we're gonna hope that by the time you do this, you will have all talked to one another and you will have talked to Walters on Tuesday and me Wednesday. So you'll probably know a lot of the answers to a lot of these questions by the time you take the exam, and will even know that you know the answers. So the one thing is, if you really want to show that you really understand, that you're not just like copying your friend's answer or something like that, the place to really show, or put the other way, dare I say, if you want to really have fun, I mean, the place to get the most creative or really show your personal comprehension of all this would be part 4. So that's where, if anywhere, you would maybe draw a little diagram for each part. Maybe you would use more than one color. You would make clear what the question is, show some work, circle clearly the answer. Like that's what Yulia is talking about. Like if you're going to do that 5-step thing, this would be the place to do it. And again, but to Yulia, to Hannah, to Shasha, to everybody, like to Kwan, like that 5-step method, you're right, that we mean that as a very strict thing generally, but we didn't do that many homeworks. We didn't practice it that many times. It's totally true. If that's like a guideline to show you the type of expectation we have for thorough problem solving. If you solve a problem thoroughly and clearly and go from beginning to end, and like show the question, show a lot of work, circle the answer, and like it's the 5-step way is not the only way in the world. It's just a very guaranteed, very reliable way. If you're looking for assurance of showing us that you really know what's going on. But so yes, diagrams I recommend for this part, for part 4, for when you're solving each little problem. The more actual work you can show there, including diagrams, the better. But there might be a person in this class, for example, who doesn't draw diagrams, but gives so much English or something, or so many different colors, or so much something that they're fine because they showed it in some other way. Like it's like that. I hope that makes sense. Okay, I'm gonna look in the chat. Oh, okay, cool. Yeah. Okay, so cool. Yes, Yulia, thank you. Yes, Shasha, thank you. And all this dialogue in the chat, please do submit for points too, if you wish. Again, at this point, I'm not even sure that any of you need the points, but go for it. Okay. Okay, so it's 4:44. So we have an hour still. So what I strongly, we're sort of clear, I think. Oh, good idea. Oh, wait. Yeah. Given the question. Yes, Shasha, yes, and good idea, Kwan. Oh, is it okay if you could? Well, it is. So Kwan's question is a great one, totally fair. Very okay, but I think right now, it would be very helpful. No, I do agree with what Kwan's saying. I'm just a little nervous right now because I've talked so much and we only have an hour. I would definitely, let me think for a second. I mean, definitely that's what Walters is going to do on Tuesday. And definitely I would do that Wednesday. I do see why it would be helpful for me to do it right now. I'm just a little concerned because once I start doing that, I might never stop. And I really want to give you time Yeah, I apologize. Very legitimate what Kwan's asking. But also because that's part 4, and you sort of have to, I want to give you time more first to back up and look through this exam on your own. And like, because there's part 1 and there's part 2 and part 3 before you even get to part 4. So like, I promise, Kwan's request is legitimate. I see why you all want that one way or another. But remember again, please, like this thing isn't even going to happen for like 3 weeks. We've now, I think both Walters and I got so worried that we were going to leave you high and dry that we're really doing the opposite now. We were going to be so ready for this. Again, remember there's class on Tuesday with Walters, then with me. So I think right now I would rather let you try on your own first, really, and have me shut up. But I will. I promise by Tuesday or Wednesday, if you haven't seen, I will give you an example by then to straighten you out. But I'm not going to do that right now. But she is right. Yes. Yeah, right. Thank you for understanding. Wait. Oh, whoa. Wait a minute. Oh my God, you guys are so cool. Right. I mean, next week is a review as well, and we will get a chance to get to next week. I promise, one way or the other. And I appreciate your understanding. But Kazi also just reminded me, I'm not sure if this is what Kazi means. But, you know, it's also true that if you go on the YouTube channel and go to past semesters of 102, we definitely have like tapes. I mean, video. I don't know if this is what Kazi means, but for sure we've walked through this thing in past semesters, and that's on YouTube publicly for a reason. It's not cheating to go back and look at this stuff. That's what we want you to know it. We also want your friends to like and subscribe. But yeah, so if that's what Kazi's saying, yeah, she's right. And any materials you can ever get from past semesters, from past, like I know other professors have another philosophy about that, but they're wrong. So I mean, but like we just do different things here. Like we just everything from past semesters is, I mean, this is why we post it on YouTube and everything. It's not about cheating. It's about using resources. So, and it's also about, we keep running out of time. It's so any way you can get the information, God bless, Quark bless. So yeah, I think Kazi's right. I think there's, if you go to, you know, there's playlists, there's a playlist on the YouTube channel for every P102 from all the past semesters since COVID started. And, you know, some are definitely more organized than others and some are, but if you poke around, you can find, yeah, that is what you mean. Okay, great. Oh, I did it on this semester. Oh, okay, great. Maybe so. Oh, yeah. Because once upon a time I was responsible about the homework. Yeah, I think early there's a homework example. I think Hannah's right. Yeah. So one time early in the semester, I did walk through a homework question and show you how to do it. Thank you. And that was the point back then. But I know we got all funky about homework, which I keep feeling guilty about. But that's true. So yeah. So there's models all over. So don't forget to like and subscribe. But okay, it was for homework too. Look at you guys. Oh my God. But please also remember, and I really need to shut up for your sake and because all this talk is good, but like if we're trying to learn how to play the piano, at a certain point, you have to sit at the keys yourself, right? Like we know this. So I need to shut up. You need to practice, but I also need to say, okay, fine. And speaking of love, also don't forget when this is all over, I feel there are many of you in this room, just about all of you, that I actually feel like I know better now than sometimes professors know students, even in a regular non-COVID in-person class. And I'm saying that not only as a thin compliment, I mean, not only as just an empty compliment, but as a, when it comes time that you need recommendation, and I'm saying this to all of you, but I'll speak to any of you individually, personally about this. When it comes time that you need recommendations, whether for a summer thing or for medical school or for graduate school or for a job, please don't hesitate. I think you all have, and this also for the sake of the exam also, you text me, identify yourself. Oh yes, no, please, I will be delighted and we'll talk. I mean, there's a process for that, but, and the fact that I can say about you people, like it's a whole new world now, right? But I know I already have a recommendation in my mind for many of you where I could say, despite all of the obstacles of online learning and social tragedy and the grim reaper being in the back of the room for every one of our classes, these students really, really stepped up and engaged in a way that that would be unusual and impressive even in an in-person setting. Like I can say that about you people. It's a whole different type of recommendation that can be written now. So I do encourage, and so, you know, please do come to me when it's all over. Yeah, of course. No, really. I mean, so we'll talk. So then that becomes an individual conversation for you. So just reach out to me by text and let me know, blah, blah, blah. But that's, of course, after you get, anyway. All right, so now, but I do mean it. No, thank you. I know, I totally, yeah, of course. And I'm sorry if that's not clear, if that's not already clear. Okay. No, thank you. Well, oh my God, look at this. So everybody really is paying attention. Jeez, even people, I'm getting more. All right, great. No, I mean, now I triply mean it because you're all there. All right, but I'm going to shut up. I'm not going anywhere. I'm just going to shut up. I encourage, I'm going to turn, well, I'm not going anywhere, but I might turn off my video. I'm not sure, but you should start working on this. If you want me to, I'm not going to make breakout rooms because I don't think, unless you tell me in the chat if you want me to make breakout rooms, but I suspect you don't want that. But I do encourage you to contact each other, like right now, like whether it's through your phones or through Discord or something, but like, okay, so I trust you and I trust you too. You can walk back and forth. I'm leaving the thing on in case there's issues and also because it's class time. I'm here. I'm not going anywhere. I'm going to grade some other papers. But I encourage you, just go for it. Start, like, pretend it's the exam. Just start, like, take out but don't write on the thing. I mean, even if you print it out, write, you know, practice writing on fresh white sheets of paper, like with a pen that you would eventually scan in. You know, just practice like it's as though it's the real thing. Wait, you guys see? Oh, you have a group chat. Great. All right, so use it. Go. All right, so let's go. So we've got like 45 minutes. Let's do this. And I'm saying like maybe at about 5:30, you know, you can ask, we'll make sure there was no major questions or confusions, but until then, let's just like quietly work.